7.4, basic concepts of probability. We start with the union rule for probability, and that should look familiar. We had the exact same rule for the number of elements in a set, but I remember it as double equals single plus single minus the other double. But that P just stands for probability. We're talking about probabilities. It's saying the probability of the union is equal to the probability of the single set plus the probability of the other single set minus the probability of the intersection. All right. So have that handy. You're going to use that at times. Number 1 says if a single card is drawn from an ordinary deck of cards, find the probability that it will be red or a face card. So let's do this. Red or face. So probability of red or face is going to equal the single probability of red plus the single probability of face minus the opposite double probability of red and face. That's the way I remember the union rule. So we talked about some probabilities for playing cards. Probability of being red is 26 out of 52. There are 26 red cards out of the 52 total. Now the face cards, do you remember how many face cards there were? 12, very good. King, queen, jack of the 4 suits, that's 12 face cards. But what has happened here is we've counted some of them twice because some of the red cards are also face cards. They've been counted in both of those sets. And so what we do is we subtract off the overlap. If you picture a Venn diagram, there'd be some that have been counted twice. Okay, so how many cards are red face cards? 6, because we'd be talking about king, queen, and jack of hearts and king, queen, jack of diamonds, right? So there are 6 cards that are red and face cards, and so we would subtract. Simplify that. You'd have 26 plus 12 is 38. Minus 6 is 32. I see 32 over 52. And we can reduce that fraction. Both numbers are divisible by 4. That's 8/13. If you wanted to find a decimal, just divide 8 by 13, and that's going to be about 0.615. Sometimes you'd prefer to see the decimal point, but the problem with the decimal is it's only approximated. Okay, the fraction is exact. Number 2, suppose 2 fair dice are rolled, find each probability. Part A says the first die shows a 2 or the sum of the results is 6 or 7. Okay, so let's do this. We want the probability that the first one is a 2 or the sum is 6 or 7. Okay, so the union rule is going to say that's equal to the probability that the first one is 2 plus the probability that the sum is 6 or 7 minus, I'm out of room here, minus the probability of both. The first one is 2 and the sum is 6 or 7. So the probability that the first one is 2, I've got that little image there of all the different ways you could roll dice. Okay, so if you look at the first one being 2, let's do this. That'd be like this entire row right there. Okay, that row is showing a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4, a 2 and a 5, and a 2 and a 6. So there are 6 results where the first die is a 2 out of 36 possible outcomes. Now we're going to look at the sum being 6 or 7. So the sum being 6 or 7, let's look at that. Let's see. The sum is 6 for like all of these, and here's 7. Sum is 7, 7, 7 right there. Okay, I just circled all of the ones where the sum is either 6 or 7. So if you count those, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 different outcomes where the sum is either 6 or 7 out of the 36 possibles. Okay, now if you notice, I highlighted a couple and circled a couple twice. All right, there are some outcomes that have been highlighted or circled in both of the cases. So I've overcounted, and I'm going to need to subtract off the overlap. So if you notice, we're at right here. Those two have been counted twice. So I'm going to subtract off the number where the first one is 2 and the sum is 6 or 7 out of 36. And that's going to give me my answer. 6 plus 11 is 17, minus 2 is 15. So we're going to get equal 15 over 36. Divide by 3, you get 5/12. That's the probability there. B, the sum of the results is 11 or the second die shows a 5. Probability the sum is 11 or the second one is a 5. So the union rule is just going to say probability that the sum is 11 plus the probability that the second one is 5 minus the probability that both of those things happen. Sum is 11 and the second one is 5. Okay. So sum is 11. That's what? These. Nope, that's not 11. That's 10. Oops. 11 right here. These two. There's only 2 of them that have a sum of 11. So 2 out of 36. And then the second one is 5. The second die is 5. That's these 6 right here. Okay, 6 out of 36. But you notice how I circled one of those outcomes twice? I circled one of them in red and one of them in blue. That's the overcount. We're going to have to subtract off the overcount. That's the overlap, or the sum of 11, and the second one is 5. So subtract that 1 out of 36. And our answer is going to be 2 plus 6 is 8, minus 1 is 7. We get 7/36. Next is the complement rule, and it looks complicated, but we use it all the time. I like this version better right here. The probability of the complement equals 1 minus the probability of the event, okay? So, you know, let's say you look at the weather forecast and it's a 30% chance of rain, okay? 30% chance of rain. What we never think about is it's actually a 70% chance that it doesn't rain, right? That makes perfect sense. That's using that complement rule. If we know one of the probabilities, then just subtract from 100% and you've got the other percent, right? That's exactly what this says, okay? The probability of the complement is equal to 1 minus the probability of the event itself. So if a fair die is rolled, what's the probability that any number but 5 will come up? We could write it like this, probability of not 5. And you can probably do that one in your head. It's so easy. But it would be 1 minus the probability of rolling a 5. Now, I know you can do that in your head, but probability of rolling a 5 on a fair die, 6-sided die, is 1/6. So 1 minus 1/6 is 5/6. And that should make perfect sense to you because you know there are 5 outcomes that are not a 5. So let's get a little bit more complicated. 2 fair die are rolled, or dice. And there's the picture of two fair dice being rolled again. Find the probability that the sum of the numbers rolled is greater than 3. Well, greater than 3, I'm talking about a sum of like 4. So if you add up the numbers on the dice, all of those would have a sum that's greater than 3. I see a sum of 4, a sum of 5, a sum of 6, 7, whatever. So what they're saying is if we want to find the probability of the sum being greater than 3, it might be easier to just subtract off the probability that the sum is less than or equal 3. So instead of counting up all of those numbers or all of the outcomes that I circled, instead, let's just count up all of the ones that I didn't circle. Like these. There's only 3 of these, and I can see that really quickly. So the probability that it's less than or equal 3 is 3 out of 36. So 1 minus 3 out of 36, or get a common denominator, 36. That's going to give you 33 over 36. And then that reduces to 11/12, which would be your final answer.